Okay, guys, today we're going to be doing K12 in IXL, graphing compound inequalities. Now, this one is going to be easier than K13, but both are going to be pretty manageable. So let's start here and realize that this is all written together. So this is an implied and. It's saying 5 is less than or equal to x, and x is less than 9. So these are two separate inequalities. I'm going to break them apart right now. So let me do this. So here I have 5 is less than or equal to x. 5 is less than or equal to x. So I can write that as x is greater than or equal to 5. And intersection. Okay. Over here, I'll use the blue. X is less than 9. Okay. So I'm going to start by graphing this one over here. X is less than 9. I'd have an open circle at 9 with a line extending to the left forever. I'll go back to the other color. Let's go back to red, reddish. X is greater than or equal to 5. That would be a closed circle at 5 with a line extending this way forever. In an and statement, they must overlap. So here we're overlapping from the 5 to the 9, but not including the 9. Okay, so what we're going to do here is we're going to graph from the 5 to the 9 and open circle the 9. Okay, so here you can see the way it's written here, it's any value between 5 and 9 is going to get graphed. Any value between 5 and 9, including 5 but not including 9, is going to be on that graph. And this is a conjunction or connected overlapping graph. Okay, now we got another one. I'm not going to do as much drawing. I wanted to over explain the first one, and now we'll move a little quicker in the second one. So like we said, this is 2 is less than x, or x is greater than 2. So from 2 going in this direction forever, and x is less than 3. So from 3 and a line in that direction forever. You'd have an overlap from 2 to 3. It's basically saying is x is any value between 2 and 3, but not including 2 and not including 3 because we don't have the equal to. So here we have our conjunction because this is a implied and statement. It's connected from 2 to 3. All right, we have another conjunction, another connected graph. This is 3 is less than or equal to x, which means x is greater than or equal to 3, and x is less than 9. So x is going to be any value from 3 to 9, but we're not going to include 9 because there's no equal sign here. And here's our conjunction, our connected graph. So any point in here correctly meets both conditions. 6 is both greater than 3 and less than 6, or less than 9, excuse me. Okay, a lot of conjunctions here. We're starting off with a lot of and statements. So basically, x is anything from -1 to 8. So x is greater than or equal to -1, and x is less than 8. So our boundary is at -1 and runs all the way to 8, but does not include the 8. Okay, here is another way of writing something this similar. I'm going to just draw this underneath for a second. Okay, so here we have x is greater than or equal to 2, so that would be a closed circle at 2, and a line extending to the right. Okay, we will go with blue here. X is less than 4, and that would be an open circle at 4 with a line extending to the left. Okay, the overlap occurs from 2 to 4, but does not include 4. So from 2 to 4, but doesn't include 4. Okay, another conjunction. So this is an implied and statement. It's all connected. So -2 is less than x, and x is greater than or equal to -1. So we're taking every point. X is going to be trapped in between -2 and -1. Okay. But it does not include -2. It does include -1. Okay. We have our first or statement. So in an or statement, if it meets one condition, it must go on the number line. So I'm just going to start over here with the x is less than -4. That is a -4 is our boundary. We don't actually want this point. So I'm going to click it open, and then I'm going to drag everything to the left. And that is x is less than -4. Or, which means we're going to skip some things. We'll take anything less than -4, or we'll take anything that is greater than -2. But we do not want -2. So basically, just this region of the number line is not going to be used. So this is, again, an or statement, which is a disjunction. A disjunction means there's going to be a break in the graph rather than the graph being connected. Okay, now again, it's connected. So we've got from, the numbers are getting bigger, but it's nothing to be worried about. So 544 is less than or equal to x, and x is less than or equal to 547. So any value between 544 and 547 will make this true. Okay, it's starting to look a little bit more complicated, but it's still the same thing. Now, this is an and statement, so it's got to overlap. Let's draw it out real quick. We've got over here, x is greater than -734, so that'd be an open circle there with a line heading that way. And we'll go yellow here. We've got x is less than -731. -731, we have an open circle, line extending here. Now, an and statement is an overlap, and we overlap from here to here. So anything in between meets both conditions simultaneously. Okay, so -732 is both less than this and greater than that at the same time. Okay, so from here to here, not including the endpoints. Okay, I think we'll end on an or statement. So here we have, if it meets one condition, it's got to get graphed. So x is less than or equal to -986. There's -986. We want to include that point. We want everything less than that. Or x is greater than -984, -984, but not that point, and everything greater than that. This is a disjunction, and it's not connected.